Let's look at some examples of how to graph a quadratic equation or function using the axis symmetry when it's in standard form. So here we got an equation. We know the axis symmetry is x equals negative b over 2a. So the axis symmetry here is going to be negative 2 over 2 times 1, which is negative 1. When you simplify that. Now to find the y-coordinate of the vertex, so that's the axis symmetry first of all. Okay, so we know over here, let's go over to our graph. And if we're at 5, and negative 5, we know that at negative 1, there's our axis of symmetry. That's going to cut the parabola in half. So we got to find the vertex. The vertex is always on the axis symmetry. So to find the vertex, we're going to plug in negative 1 into this x value and see what we get. We get 1 minus 2 minus 3, which is negative 4. So that is the y-coordinate of the vertex. So we now have the vertex. Our vertex is at negative 1, negative 4. So we can plot that over here at negative 1, negative 4. 2, 3, 4. There's our vertex. Negative 1, negative 4. That's our vertex. All right? Now, we see that this has an x value, or an a value, I should say, of 1. So the a value determines the shape. So if a equals 1, then we know this is going to look like a regular parabola. The regular parabola y equals x squared. And when we're graphing y equals x squared, we've got our vertex. And when we go right 1, we're going to go 1 squared is 1. So pretend like this is the origin. And so 1 squared is 1. And now from the origin, or from the vertex, 2, go right 2. 2 squared is 4. So let's go up 4. 1, 2, 3, 4. Okay. Left 1, 1 squared is 1, negative 1 squared is 1. And negative 2 squared is 4. 1, 2, 3, 4. So the shape is the same as y equals x squared. There's our parabola. Okay. Now, let's take another one here with this a value of 2. Let's find our axis of symmetry first. So we know x equals negative b over 2a. In this case, it's negative 8 over 2 times 2, which gives us 8 over 4, which is 2. To find, that's our axis symmetry. We're going to need to find our y value next. So, but first of all, let's go ahead and graph that. So at 2, x equals 2 is our axis of symmetry. That's the line that's going to cut the parabola in half. X equals 2. Okay. Now we want to find out where g of 2 is, because that's our y-coordinate. So we're going to plug in 2 for all the x's. So we plug in 2 for all the x's. We've got, this is 2 times 4, which is 8, minus 16, plus 9. And that's looking like 1, right? Okay, so that means our vertex, we found our vertex. Our vertex is at 2 because of this 2 right here. And when we plug in that 2, we get 1. Right, 17 minus 16, yep. So the vertex is at 2, 1. So over here, 2, 1. There's our vertex. Now, if we look back at our a value is 2. So since a equals 2, that tells us it's going to be a little steeper than normal. Okay? It's going to be twice as steep. It's facing up because it's positive 2. Okay, but we're going to go normally from the vertex. We normally go right 1, and 1 squared is 1. But this is 2x squared. Our a value is 2, so we're going to go right 1, up 2. And let's find another one. From the vertex, normally when we go right 2, 2 squared is 4. 1, 2, 3, 4. So we normally end up here. From the vertex, right 2, up 4, because 2 squared is 4. But because our equation said y equals 2x squared, dot, 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 then instead of going right 2 and up 4, we're going to double that. So right 2 is going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8, right up there, on top of there. Now, we know that the left side, this is going to be symmetrical, so all these points on the left are just going to be a reflection. So we can just copy those down, and then we're ready to draw our graph. Okay? So we find the vertex, we use the a-value to plot some points, and we get our graph. All right, one more here. We've got the axis symmetry. We know that x equals negative b, which is 10 over 2a, which is going to give us negative 10 over negative 4, which is 5 halves. Okay, so 5 halves is also 2.5, so there's our axis. So our axis of symmetry, the equation is x equals 5 halves. 5 halves, again, is 2.5, if you want to think of it that way. So let's label our axes. 5, 5, oop, that's 4. 5, and negative 5. 1, 2, 3, 4, negative 5. Okay. So we know our axis of symmetry was at 2.5, right? So it's like right down here. So there's our axis of symmetry. That's going to cut this in half, 5 halves. Now we're going to plug this in. We're going to have to do a little bit of fraction work. H of 5 halves. So that's going to give us negative 2 times 5 halves squared plus 10 times 5 halves minus 7. So that's going to be negative 2 times 25 fourths plus 50 halves minus 7. Let's clean that up. That's negative 50 fourths plus 50 halves minus 7. And this is negative 25 halves, right? We'll keep this as 50 halves. And this is, let's go ahead and make this 14 halves. Need a common denominator. And this is 50 minus 25, that's 25 halves. 25 halves minus 14 would give us 11 halves. Check that out, should get 11 halves. So that gives us the vertex. So we know our vertex now is at, our x-coordinate is 5 halves. That comes from our axis of symmetry. And our y-coordinate we just found to be 11 halves. Now for graphing's sake, just think about these as decimals. So 5 halves is 2.5, and 11 halves is 5.5, somewhere up here. Okay? So there's our vertex right there. Now, let's find our a value. Our a value is negative 2. So we're thinking there that a value is negative 2. That means it's going to flip upside down and be a little steeper. So when we're graphing this, we're going to think of what y equals negative 2x squared looks like. Okay, and this was negative 2x squared plus something else, but let's just, the shape is going to look like negative 2x squared. So we've got our vertex. Now it's going to be a little tricky because we're in the middle of the square here. So we'll just count middles instead of count lines. So normally we go right 1. 1 squared is 1. We go up 1. But we're going to go right 1 and down because it's negative. And we're going to double that distance. All right? So we're going to end up there. So we went right 1 from the vertex, right 1, down 2. We're counting middle spaces now. From the vertex, we go right 2. 2 squared is 4, but we're going to double it because of this negative 2. And we're going down. 2, right 2, down 8, doubling the 4. 2 squared is 4, so we double it. 1, 2, 3, 4, 6, 7, 8. Be right there, okay? We can reflect these across the axis of symmetry. And now we've got enough points to graph it. It's pretty steep. Let's try that again. Okay? Something like that. There's our parabola. Okay? So one more thing. So how we can apply this, how we can use this is we want to find a maximum or a minimum. To find a maximum or a minimum, find the vertex. So the key is that the max and the min happen at the vertex. So that's the key. So we got to find the maximum or the minimum, and that's at the vertex. In this case, we want the maximum height of the ball. So we're throwing a ball in the air. So the height of a certain ball that is thrown off a 20-foot building can be calculated using this function. H of t is the height in feet, and t is in seconds. We want to find the maximum height of the ball, all right? So to find the maximum height, we're going to need to find our axis symmetry. It might help to write this in descending order. Negative 16t squared plus 10t plus 20. That gives us our A, B, and C. Because we know the axis symmetry, we've got to find that first. Okay, the axis symmetry happens at, let's see, the axis at it's x equals negative b over 2a. In this case, it's negative 10 over 2 times negative 16, which is, negatives cancel out, 10 over 32, which is 5/16. Now, so 5/16 is the time where this is going to reach its maximum, okay? And so now we're going to calculate h of 5/16, and I think this one we're going to go ahead and do with a calculator, and that's fine. So, because it's an application problem. So we're going to plug in 5/16 into all of this. 16 times 5/16 squared. And we'll figure out what this is. So this all comes out to be 21.56, about 21.56, and that will be feet because that's the height. Now, by the way, this 5/16 is 0.31. So the vertex is at 0.31 seconds. The maximum height will be 21.56 feet. So it'll reach the height at 0.31 seconds, and the maximum height will be 21.56. We basically just found the vertex, the coordinates of the vertex. All right, so that's how you can take an equation that's in standard form and use it to find the vertex, find the axis symmetry, negative b over 2a, and use it for a maximum minimum if needed.